doing?
Not too bad. How are you today?
I'm very well. Excited to start this new series of conversations.
Yeah, me too.
What do we want to talk about today?
Well, one of the things that I'm really interested in talking about is actually about the pre-crime application or use case for operational technology. I think brand, application is very well understood.
Huh?
But the OT application is not as well understood within the organization, and then therefore probably externally as well. And so it's a great opportunity to learn more how you position that and how customers that are using it. So maybe you could jump into that a little bit.
Yeah, I mean, I think first and foremost, I think it's interesting to note that our first customer used it for the first use case in a manufacturing facility, OT. So that's actually where it all started. And if you think about it, it's meaningful because when you are in a manufacturing facility, the critical impact of a cyber attack is the process downtime of the manufacturing facility itself, right? This customer gave me a kind of a run of the rule of thumb, if you want, a way to calculate what would be the impact of a cyber attack on their factories. That was take the revenue of the year, divided by 365 days, divided by the number of factories that they have, and that your daily cost if a facility is down. And, we lately heard of a few very large scale impactful attack on manufacturing companies, and we see how the numbers stack up very, very quickly, right?
Mm-hmm.
So I think that there are three use cases that we have seen in this industry. They're all specific to the network protection for these OT networks. So it's the pre-crime intelligence solution of ours. And the first one is a very classic filtering solution, right? So they have multiple perimeter security controls, OT firewalls, OT DNS resolvers, etc., data diodes. You want to feed those peripheral with the intelligence that we have, so to block communication to future cyber attack sources before they even start, clearly eliminating the downtime risk. And so that's kind of nothing really innovative compared to what we do already on IT networks. But the reality is that most of the OT networks are already in full block. So they have either physical characteristics like their air gap, or they have specific security controls like data diodes that enable communication only one way, as in either data out or data in on specific business rules. So if you're in a full blocking configuration, then a new challenge arises. Is that nowadays more and more of the devices that exist in OT networks, so think CNC machines, I don't know, air conditioning system, temperature management system, I don't know, depending on the industry, obviously you'll have many different machines.
Sure.
Those machines require a network connection to do things like firmware upgrade or maintenance activities. And so what happens generally is the OT network is managed by OT operations team, not generally an IT organization dedicated to it. So, maybe the factory line manager, line number 3, need machine number 5 on the line to be upgraded, or there is a downtime, they need the technician remotely to connect in and check, what parameter have gone high wire. So what do they do? First, manually, they will have to request through a ticketing system an opening of the connectivity for that machine to the internet. Now, I'm assuming here a very well organized factory with a very well defined set of rules and processes and tooling and mapping and everything else. That's basically the exception, not the norm, but let's assume it is the norm. Then, you have this ticket. The ticket get managed by the IT team. The IT team perform a maintenance window of operation on the perimeter filtering device to allow connection that device from the outside. When that ticket is completed, the line manager will have to notify the manufacturer, get them to connect, to do whatever they need to do, and have the manufacturing continue to operate. And then often nobody close the door. And that unfortunately in many systems, there is not automated reset of the rules. And there is no new tickets that get created because the line manager has another machine to go after, not this one anymore. And so there is another sense of urgency, right? So long story short, there is a piling up of one manual, repetitive, non-value add activity that is these getting tickets, get them managed by the IT team. So it's burdening the line manager, it's burdening the IT teams. But then you have this additional risk of tickets that don't get closed, or they get closed and then they forget to reclose the door. So you have potential exposure. And by the way, what happens if the exposure is there and the manufacturer, the supplier system get compromised, right? So now that port was opened for the CNC machine manufacturers to do the firmware upgrade, maybe that server from which they do the firmware upgrade is being compromised. Now criminals can get into, right? So you get into supply chain risk and uncontrolled entry in your manufacturing facility. So very cumbersome, prone to error, increased risk. So what is the alternative? Is a dynamic allow listing. They mean everything is blocked, but automatically connection are open for those indicators of infrastructures that before AI provides preemptively. And before AI provides both malicious infrastructure prediction, but also benign infrastructure prediction. So in this case, it's the benign predictions that will be used. And so what's the end result is less manual work, less risk of error, less exposures, everything is automated. And if that machine of the manufacturing facility or provider get compromised, well, our indicator turns. So dynamically, we will stop it again. So that's a second use case. And then the third case, and is one that is definitely growing also because we are developing our product in that direction, is the protection from the impersonation of the suppliers. Now, some suppliers, unfortunately, do not have a pre-crime defense deployed with them. And so they get impersonated. These people that impersonate them, then they will try to trick the operator in, say, the manufacturing facilities or the oil and gas pumping station or whatever you, from an OT network to do some specific social engineering based compromise. And so that's another kind of use case. It's probably not specific to the OT network itself, but it's becoming more and more prevalent as an attack vector because OT networks tend to be less protected, if you want. So the people that manage them are less sensible to this type of risk. Maybe they've received less phishing training. Maybe they've received because they operate on the manufacturing floor. Maybe they don't use email. Just the culture is a different one. But definitely from a use case perspective, I would say the OT network blocking and OT network allow listing are the one that are more common for our product. And then the interesting evolution that we're seeing is that I was speaking with one of our customers or soon to be customers they're about to sign, so prospect, where they have ships. The shipping company ships have their own IT network, their own OT network that operate whatever they're shipping and the fridges and things like that. But now the people on the ship are buying Starlink devices to get much faster connection so that they can entertain themselves in these very long travels that they do over the oceans. So the next step is the shipping companies now thinking about, maybe we should use Starlink. And now we have such a better connectivity. Why don't we have more relevant monitoring of the ship and other activities? Even can go to the extreme and say remote operation of the ship. Maybe some area of the ship, you don't need to have someone always there, but it can be managed remotely. So now they're looking at using Starlink as the network device to connect the ship to their shipping operating center, call it. Well, now you have a new type of risk because you have again a mix-up of OT network and IT network and remote transmission and potential. So the future is more and more interconnected. So much like we have seen in the fraud space where with the fusion centers, I think we're going to see fusion centers also on the operating technology side of the house.
And what does deployment look like or implementation in a hybrid network like that, where you have an OT and an IT mashup? That's how does pre-crime connect the dots essentially between those two systems?
Of all, absolutely, and this is a very relevant question because most of these OT networks are air gapped. They don't have any internet connectivity.
Yeah.
How do they even get our intelligence, right? So the good news is we designed the product to work in air-gapped solution, because before AI is air-gapped ourselves, right, to protect our own systems. And so what do you have is that we can actually drop the update files in a given location, and then we don't need to know where that file eventually get sent to, right? So we had examples in military where we don't need to know where it gets deployed. And so they give us a shared location where we can drop the file with the latest updates, and we can do it with a frequency, every 10 minutes, every 5 minutes, every hour, every day, whatever is the contract. And then on the back end, they have automation scripts that take it from that location and transfer in different ways to the destination. And because before it does not need internal network information, that actually works quite well, right? So, because we don't need to have the feedback, we don't need to collect data from the inside, we don't need to have any visibility of the inside. So it's actually a superior solution from this perspective. More common too is the case in which we communicate to the IT network control. The IT network control, maybe say the firewall or the CM or the threat intelligence platform, more common. The threat intelligence platform could be connected to the data diodes, so on the perimeter of the OT network, and that's where the data for blocking or allow listing need to enter. So it is still an API. It's just a different configuration, and it varies by the brand. If it is a Dragos device, if it is a Storm Shield, if it is what have you in the network, and what kind of device it is. But we provide the data from the very basic CSV files that is pure text, and it can be read also from a filter from the 1982 to the more modern, MCP AI-driven interface, to passing through obviously JSON, passing through sticks and taxi. So all these standards exist that enable us to have certain base connectivity, and then we're definitely always open to create dedicated connectivity for those devices that are more proprietary and perhaps they need a specific version of the data in a certain format. But this can, generally be set up during the proof of value process with the customer.
Gotcha. And I would imagine a lot of those systems are proprietary because they're air gapped and they're they're built to do a very specific thing.
It's actually one of the biggest challenge, I believe, in OT. You could actually, it's always two sides of the same coin. It's actually a challenge for the criminals as well. This heterogeneous environment make for the criminals very difficult to navigate, because you have different protocols, you have different products that respond to different commands. Some commands are, some products are maybe 30 years old. It's not like something like a COBOL, programmer in banking. Do the criminal have, guys that can write in BASIC? I don't know, just making it up. But unfortunately, if we look at it from a defender perspective, the challenge is one of navigating this infrastructure. The good news is that I think there is a recognized need of upgrades that is happening in the industry. We hear more and more the resilience aspect of the industry being promoted. And an element of resilience is transparency and visibility of your infrastructure. If you don't know how certain devices and certain components of your infrastructure communicate, how can you possibly restore them after an attack or a disaster or whatever, right? So the good news is I think in OT network are generally part of critical processes, could be manufacturing, could be oil and gas transmission, could be, I don't know, water treatment, electricity transmission, etc. Those processes are designed with resilience in mind, just from a pure operational standpoint, let alone the cyber attacks, right? And cyber attacks just add a different flavor of the resilience requirement, more, kind of a IT specific. But this is, I would say that this network tend to be more robust by definition. If you think, for example, that internet protocol, when it was created, it was created for network that wouldn't work. It's one of the characteristics of the IP protocol is that even if most of the nodes in a network don't work, the message will arrive to the end. Well, the protocols of the OT network are actually on the assumption that the communication will happen, and they don't necessarily have that type of redundancy. That means that the entire rest of the system is built for more resilience. Because, the connection line are more stable, the connector are interlocked, and of course, a network cable used in a factory costs 10 times the network cable used in your house. Why? Because there is a lot more shielding. There is a lot more quality in the product itself. because it's also meant to be there for many, many more years. And so I think, that's another aspect that we need to consider in the evolution of those. And to me, the critical feedback we get from our customer is one of the cost of the cyber attack is not perhaps as big of a trouble, is the actual downtime that derives from that is going to be the problem. And so they definitely don't want to have the downtime. This also means that the whole paradigm of detection and response is kind of obsolete in their scope, because if you detect and then you respond and then you have to remediate and then you have to clean up and analyze what is left, that's already impacting your downtime. And so you want to definitely do what we love the most, that is predict and preempt, so that you don't have to detect and respond.
Yeah, the downtime factor is huge.
The systemic impacts,
Yeah.
all these smaller supplier that derive their existence from working with that factory now are at risk of bankruptcy, right? So there is a resilience of the ecosystem that come into play. There is an impact on the people, even just psychological, right? If some of them had to stay home for 2 months, not knowing what come next, do they still have a job? Let's think about what is now their worry. Maybe they just signed up for a mortgage on the house, and now they don't know if in a month time they still have a job. I think the ramification of cyber attacks, especially when they touch infrastructure of such a size and criticality, are massive. Goes back to the earlier point, why you want to be in a reactive mode and hope that you catch the criminal on time, so that the cost of remediation is not so big. And then again, we do know that not everything can be predicted. So the key point has to be balance, and try to move as much possible of the controls, shifting them left, where it's less expensive. It reduces the impact on the downstream, while maintaining focus and energy on where it's really critical to have detection and response, like with insider risk that cannot be predicted, or with things like attacks that derive from nation states that may have different motivation and hence employ different type of techniques, some of which we have been hearing lately with deep fake on hiring scams and stuff like that, right? So those tend to be another type of risk. The key point here is today the industry has moved to maybe 10% prevention, 90% detection and response. Let's move it more to 10% prevention, 30-40% prediction and prevention and preemption, 50-60 in detection and response. I'm not saying that it should disappear, just that we need to have a more balance.
Yes, definitely. Well, that's very interesting. I think one of the big takeaways for me is sort of like the utilization of pre-crime intelligence in reverse, almost like the idea of, of leveraging the benign predictions is really interesting. And that helps me understand the system a lot better in terms of its OT use case. So thanks for that.
You're welcome. And, again, it's still something we're still discovering. I mean, the beauty of pre-crime is that the use cases to which it impacts are still unknown even to us. And in fact, something that we are doing more and more are those design partnerships to work with more advanced and sophisticated users that can push us to figure out new ways of using the technology, right? So I think, like the shipping and Starlink connection use case, I think in a world where there is more and more convergence, where interconnectivity enable new use cases every day, the use of prediction and preemption is just at the start of the journey. So whoever will see this video, if you have a problem and you don't want to be reactive in solving it, contact us. Maybe we'll figure out a way to help, or if anything, we'll just share a thought and then we will have made a connection.
Yeah, awesome. Well, thank you very much.
Thanks for today.
Appreciate your time.
Till the next time.
Yeah,
Bye, Andy.
Talk to you again.